So as the board says, right, initial knowledge check due tomorrow. Questions on homework, you can come see me bonus. I'd love to talk to you about it. That'd be great. Today 5.7, tomorrow 5.8. I hand back the homework. Monday we're reviewing, going over the practice test. And then on Tuesday is the test. If you have extended time, you will come to bonus on Tuesday, and then we'll just go straight through A period. Coolio. All right, so 5.7, roots and zeros. So we all have our notes out with a pencil. Everyone have notes? Do you have your notes? Notes? You don't have yours? Or you don't have them at all?
In my bag. No.
Where's your bag? Okay, so make sure, do you have paper?
No.
Okay, does anyone have some spare? I have spare paper.
Oh, yeah, I got you. Something
I have
that I
spare
have
paper,
for
it's
work.
fine.
I'll tell you, here's a piece of paper, huh?
Alright, here's 2 pieces of paper. Do you have a writing
I
pencil?
just gave you one.
Okay, so borrow one from someone and you can follow along.
Dude, I felt so special.
So one part of participation is following along and taking notes, right? It's expected you to follow along and take notes. So 5.7, we're going to start with an easier problem, one that you probably already know how to do, right? That's the idea. Okay. So we have the potential to finish this early and give you time to work on Alex and homework, but only if we get through it. So if you talk, and I've asked you once already to stop talking, you're going to be marked down. If I have to ask you more than once to stop talking, I'm also going to email your parents. I'm over this like nonsense of talking and being like unrespectful. Right? We gotta focus. I want to make sure we understand this. Okay. Okay. 5.7, roots and zeros. It's only about 3 pages of notes. So the word zero, this is the same thing as saying the root, the x-intercept, or solution. All 4 of those words mean the exact same thing. So one thing I want you to note is the difference between a factor and a zero. So if I say f of x equals x squared plus 5x plus 6, the 2 factors are x plus 2 and x plus 3. All right, remember, they add to the middle and they multiply to the outside. So the factors are literally x plus a number, x minus a number, right? It's the ones when they're in parentheses with x. Versus if I want the roots, if I want the zeros, that's when you set the factors equal to 0, and our zeros would be -2 and -3. Because if I set x plus 3 equal to 0, subtract 3 on both sides, we see, oh, x equals -3. Right? Same way we find x equals -2. So these are the factors. These are the zeros. Okay, so that's the distinguishing feature. One has x equals, the other is x plus or minus a number. Okay, so something interesting is if I start with my zeros, I can actually write a bunch of different factors. So, first question, how many zeros does this function have? 4. All right, I see a bunch of people holding up their hands, 4. So here's 1, 2, 3, 4. 4 zeros. That's the number of zeros. Now, if I want to know what the zeros actually are, one of them is x equals -3, x equals -2, x equals 1, and x equals 2. These are the zeros. All right, another word for zeros, x-intercepts. Right, they're the roots of our equation. They're the solutions. Now, if I want to write them as factors, can anyone tell me what the first one would be as a factor? Cooper. Right, because I add 3 on both sides and I see, oh, x plus 3 equals 0. So I could write it as x plus 3 as a factor. So remember, when we have a bunch of factors right up here and we went to solve them, you literally set the factor equal to 0 and then you find the root that way. So if I get it by itself and set equal to 0, that will be my factor. All right, so let's try the other ones. I'll just go down the row. Kaylin, what's my next factor?
X plus 2.
Exactly, just move it to the other side, x plus 2. Jordan, what's my next factor?
What?
What's my next factor? So we're moving the 1 to the other side. How do I move to the 1 to the other side? I want to move it to the other side, so I subtract 1. So this will just be x minus 1. And lastly, Felix, what's my last factor?
I'm so sorry, I was spacing out the entire time.
Okay, let's go back. Jordan, what's my last factor? What's my last factor?
Oh, -2.
Right, x minus 2. So I explained it to Jordan. All right, you got to be paying attention.
Yeah, I got you.
Okay, so these would be all my factors. Fun fact, if I take all 4 of those factors, now we're not listening again.
Sorry, that was so funny.
Okay. Okay, you got it like somehow inside. You just got to pull it together. Okay. All right, fun fact. I don't know, not fun fact, just a fact. You take all 4 of these factors. If you multiply all 4 of these together, you know what we'll get? This polynomial right here. We'll get this exact polynomial. So you can start with the zeros, write them as factors, you multiply them together, you can find a polynomial.
Are we gonna have to do that?
How do you have to? Like the
Just, okay. First question, Kaylin, will you have to do that? Yeah, 2 or 3 zeros. I'm not gonna make you do 4. Yeah. Okay, that's just an example. So we know the difference between factors and zeros. Let's give you an easy question that you know how to solve. Okay? But this time, are you looking for the Kleenexes? I think they're over there. Okay, so example 1 is we're solving the equation by factoring. Right? We're going to find the x-intercepts and then state the number and the type of roots. So the number of roots up here, we said there were 4 roots, right? 4 x-intercepts. But what were the type of roots? Well, there's only 2 types, right? You either can have real or you can have imaginary. So we have 4 roots here. They're all real, so we have 4 real roots. Okay, let's try this first one. So I want you to try factoring it, right? Factor, do it on your paper, try factoring. All right, Adi, I need you to factor. We're going to focus. So we're looking what adds to 2 and multiplies to -48. Who thinks they have it? All right, Jesse.
-6 and -8.
So close. X equals -6 and x plus 8. Because they have to multiply to -48, add to 2, right? 8 plus -6 is 2. And then, Jesse, how do I finish by, so you factored, but we got solve. How do I solve, Jesse?
Then you put them both equal to 0. So
Yeah.
X minus 6 equals 0 and x plus 8 equals 0.
Good. And one of my solutions is x equals -8. The other is x equals 6, positive 6. So I solved by factoring, right? I solved. Those are my solutions. So now I have to state the number and the type. All right. Doreen, right? Doreen? Okay, I'm gonna get it. Doreen. All right, how many roots and what is the type? Yep. Exactly. So I say 2 real roots.
If they weren't real, would be I.
Hold on. Wow.
Not you.
2 questions then. Okay. So the directions say state the number and the type. So the type here, we're just going to specify real or imaginary. And the number, since there's 2 roots, we say 2. This is for,
like 1 negative.
so that's the next thing. So we're working towards that. That's the next page is Descartes rule of signs. So we're slowly working towards that. Okay. Now let's try the next one. This is a little harder, but it's still doable. What does it look like? Does it remind you of anything? Right, Vanna Whitetime, blank of blank. Difference of squares.
Oh my god.
Ah, difference of squares.
Oh.
So think about this. What times itself is x to the 4th power?
X squared.
Yeah. Okay, so I'll have an x squared times an x squared. And difference of squares, literally the same number. One's plus, one's minus in the middle.
16.
Yeah. 16 times itself is 256. 16 times 16 is 256. So x squared plus 16, x squared minus 16. So pause here for a second. Can we factor further any more?
Yes.
Are we done? Yeah?
It's 4.
Like this one is also difference of squares. Exactly, yeah, x plus 4 times x minus 4. Because that's a difference of squares. What?
You can only do the one with the minus there, right?
The difference of squares, do you remember what difference of squares is?
Difference means subtract.
Difference, subtraction, and two things that are perfect squares. X squared is a perfect square because x times x is x squared. Wait, you mean the order?
Yeah, what do we?
Okay.
Can't you?
Oh, wow, we have lots of questions. So raise your hand and I can answer them in order. Okay, we'll do Natalie, because I'm not done with the problem. I haven't written the rest of my line yet.
Oh.
I'm doing one thing at a time, but I keep getting just stopped by questions. Okay, so first thing I did was a difference of squares, right? X squared times x squared is x to the fourth. 16 times 16, 256. Difference of squares is the same. It's literally the same thing, but one of them has a plus in the middle, the other has a minus. Remember, for the factors of difference of square. This is also a difference of squares because I'm subtracting, right, two different squares. 16 is a perfect square. 4 times 4 is 16. X squared is a perfect square. Imagine x times x is x squared. But what about this left side? The x squared plus 16, that's not a difference of squares. It's not a difference of squares, right? So I have to drop it down. I can't simplify it anymore. Okay. So now that I have it fully factored, I'm going to go and set each factor equal to 0 and solve. Yeah, so it's not really different than what we did before. It's just having this to the fourth power kind of freaks people out. But it's doable. So you set each factor equal to 0. So I'll set x minus 4, right, equal to 0. Add 4 on both sides, right? These two, this intermediate step, I'm not going to show for these right two because we've done it a billion times. But the left one, the x squared plus 16, this is a tricky one. I set x squared plus 16 equal to 0. We're trying to get x squared by itself. So x squared equals negative 16. And if I square root both sides, I'll have plus or minus the square root of negative 16. So I'll pause here. We know how to deal with these. Throwback, chapter 4, I think section 4 or 5. You say I, yeah, I. Imaginary numbers, I. Okay. So, this right here is root negative 16 is the same thing as saying root negative 1 times root 16. So that's why this is going to be plus or minus 4i.
Is that negative 1 or negative
Negative 1, because I just pulled out negative 1 from the negative 16. Okay, so in summary, here are my solutions. Plus or minus 4i and plus or minus 4. If you don't like writing it that way, I'll show you the other way. 4i, negative 4i, 4, and negative 4. That's all the plus or minus means. You have a positive number, and then you have the same number just with a negative sign in front of it. So I think I'm back to a D. The number and type of roots. You're up. So the number and type of roots. Yes. How many roots do I have? I have 4 total roots, but how many of each type? 2 real roots and 2 imaginary. So I have 2 real and 2 imaginary. How can you tell when you have imaginary roots? Yeah, because there's an I in them. 2 real, 2 imaginary, right? These are the imaginary, the ones with the I in it. Let me pause here. Do we have questions over these first 2? Okay, so I'm trying to help you guys see, like, okay, so we have imaginary roots. All that means is, like, they're not actually x-intercepts, because at those points they don't touch the x-axis. So this is warming you up for the next thing we're going to learn, which is Descartes' rule of signs, which tells you how many positive real roots, how many negative real roots are possible with your polynomial. But then it's kind of like you're making a hot dog. You're literally, you know how many total roots possible you could have. Imaginary is always your filler. So I'm going to use that same analogy in a little bit. All right, let's try the last one. Hopefully I have enough time to write things down. So think back to chapter 4 when we were studying factoring. What's the very first thing we always try? Very first thing we always look for when we're trying to factor. Greatest common factor. What's the greatest common factor? What is in every term? X. There's an X in every single term. So I'm going to pull it out. And I'm left with x to the 4 minus 8x squared plus 16 equals 0. Alright, so this is a little confusing because you have an x to the 4th term. There's like a trinomial. What's going on? But imagine that the problem, instead of looking like that on the left, imagine it was x squared minus 8x plus 16, right? It roughly looks like the quadratics that we factor. Hence, we'll say like it's, in quadratic form. How would you solve the blue one on the right? All right, that's a little easier problem. How would you solve it? So it adds to -8, multiplies to 16. Do we know? Yeah, -4, -4. So x minus 4, x minus 4. So the only difference between this one on the blue and the green one is instead of saying x minus 4 and x minus 4, the one on the left would be x squared minus 4 times x squared minus 4. It's in roughly quadratic form. Because you see how it goes squared to the first and nothing? On the left side we have to the 4th, to the square, and nothing. Yeah, it's the window shade in the other room. It happens all the time. Yeah, wild. Okay. Am I fully factored? Is this green line that I wrote fully factored? Don't say it out loud, but just think. What could I use? Do you recognize? Jordan, what do you see?
2.
What 2?
X squared minus 4 is x minus 2.
X minus 2 and x plus 2. Because it's a difference of squares. Right? This is a difference of squares. But we have it twice. And then I'm going to bring down my other factor. Okay, now it's in fully factored form. I can go through and I can solve. Okay, I'll pause here for a moment.
Where do you get the x?
Because I factored it at the beginning. Yeah. I can't forget about it.
Hold on, what?
The x in the front?
Oh, I didn't finish.
Oh, okay.
The x plus 2.
The difference of squares? What times what is 4? 2. Difference of squares?
Oh, you just factored it out.
Yeah, that's what the red is showing. Factor. That was my intention. Yeah. Okay. Set each factor equal to 0. When I set x minus 2 equal to 0, I see, oh, x equals 2. X equals -2. X equals 2. So notice that these repeats, right? X equals 2 repeats, and x equals -2 repeats. So at the end, when I'm listing out all my zeros, literally my zeros are 0, -2, and 2. I only have 3 roots, and I think I'm on Carly. What's the type of roots I have? Shh. I didn't say roots of fruits. Yeah. What type? What'd you say? Real. We got 3 real roots. That's all we got, right? 3 real roots. Wonderful, wonderful. Okay. Here's the deal. So there's a thing called multiplicity, right? If you're a twin, there's literally multiple of you, right? There's 2 of you. If you are multiplying, you're like making it go many times. So multiplicity, we talk about multiplicity when we have a root that happens multiple times because it repeats. So imagine multiplicity is how many times it repeats. What's the multiplicity of 0? How many times does it repeat?
0.
It only happens once. It doesn't. So multiplicity is literally how many times it occurs. Multiplicity of 1. What about x equals 2? How many times does it repeat? I guess that's a bad way of asking it. How many times does that root occur? Twice. Multiplicity of 2. All right, both of these are multiplicity of 2 because it just repeats twice, right? It happens twice. Okay, so now we're ready for the main event. Yeah, Descartes' rule of signs. So it's called Descartes, right? He's a French dude. So I'm gonna warn you, right? You gotta really make sure we focus. It's gonna be super confusing at first, right? 100%. I'm being honest with you, but I tried to break down the method so it's just very approachable, right? You just gotta do the method and then you'll be solid. Okay, so we just have to have positive mindset. You guys can do this. We just gotta make sure we follow the rules. All right, so the fundamental theorem of algebra: every polynomial degree higher than 0 has at least one root in the set of complex numbers. So we kind of already talked about this. If I have something like x to the 6th power, how many zeros could I have? Yeah, we could have 6, right? This is the maximum number of zeros we could have. So the corollary, right? If a polynomial has degree n, then it has exactly n roots in the set of complex numbers. Wait, what does complex mean? Complex numbers are? Do we know? So real numbers are rational and irrational. Rational and irrational. But what I'm talking about, okay, what about real and imaginary, right? Real and imaginary are the complex numbers. So remember like that, almost like bullseye I drew for you when we were studying whole, natural, integer. Yeah. No? Okay, maybe. So if I have rational, right, these are all my rational numbers, and then these are my irrational, all right, and these make up my real numbers. Well, if I tack on all the imaginary, all of these together are complex numbers. Okay. Okay, cool. That's what you need to know. So, Descartes' rule of signs. When investigating a polynomial function to determine its roots, it could be helpful to know how many possible roots that are real are positive. How many negative real roots could we possibly have? And how many imaginary could we possibly have, right? These are all the possible roots that we could have. So, all of this gibberish right over here, I'm going to try my best to break it down as simple as possible. You just got to stick with me. So, we have a polynomial. It's got real coefficients, whatever. The number of positive real roots is going to be the same number as the sign changes. So every time, right, I look at my terms. If I go from a plus to a minus, I add 1. Keep going, plus, plus, plus. Oh, I switched to a minus. You count how many times you switch from plus to minus, minus to plus. How many times you switch your sign. And then when you're at the end, right, let's say I count 7 sign changes, right? Then when you're at the end, this is like the stop sign by, I don't know, Shoop or something, right? You're not actually home, right? When you're driving to your house, if you stop at a stop sign, you're not going to turn off the car and get out. Like, no, you got to keep driving until you are home in your garage. So home, for Descartes' rule of signs, is 0 and 1. So what you do is you just keep subtracting 2 until you are home. So is 7 home? No. Subtract 2. What's 7 minus 2? 5. Am I home? No. Subtract 2. What am I at? 3. Am I home? No. Okay, subtract 2. Now I'm at 1. This is the simplest way I can explain it. You have to keep subtracting until you keep subtracting 2 until you're at 0 or 1, and then that's the stop sign. Like, that's your garage. You're done. Goodbye. End. So what it says is the number of positive zeros is the same number of changes in sign of the coefficients of the terms, or less than this by an even number. That's why we're subtracting 2. You keep subtracting 2 until we're at 0 or 1. Okay, and then the number of let's go through part A of the example, and then we'll talk about how to find the negative possible roots. So example 2. Find the possible number of positive, negative, imaginary roots for the polynomial. Express your results in the form of a table. Okay, I have this polynomial, p of x is equal to negative x to the 6th plus 4x to the 3rd minus 2x squared minus x plus 1. Okay, step 1. Examine the sign changes of p of x to assess the maximum number of positive roots. So remember, we're just going to go through and see how many times we switch positive and negatives. So I start with a negative, right? Ooh, I switched to a positive. There's 1 sign change. I'm positive, positive, positive. Ooh, I go from plus to minus. There's my 2nd sign change. Negative, negative, negative. Ooh, negative, negative, negative. Oh, I'm done. There's no more sign changes. So how many sign changes do I have? 2. But am I done? Am I home? No, that's just a stop sign. You gotta keep going till you're in the garage. So subtract 2. So when I subtract 2, what I have? 0. So what I could have is 0 or 2 or 0 positive roots. So I tried warning you, it'll be a little confusing, but it makes more sense when we're done, right? Yeah. When you're climbing a tree, your nose is in the bark, what the heck's going on? You gotta wait till you're at the top of the tree so you can look out and see the whole problem. Okay, Cooper?
Did you put 2 because
There's 2 sign changes.
Yeah, no, but the answer is 2 or 0?
Yep. You have to include all, yeah. Yep. Because these are all the possible combos. Okay, yes.
You always subtract by 1.
You always subtract by 2. Always by 2. Yep. Because it says or less than that by an even number. I am trying to make this as foolproof as possible. So just keep subtracting 2 until you're at 0 or 1. So this next part, how to find the maximum number of negative roots. Okay, so it's the same number of changes in sign of the coefficients in terms of p of negative x. So imagine I have a negative number to the 3rd power. A negative times a negative times a negative. What happens? Right, these 2 cancel each other out, and I'm left with a negative in front. Versus if I take a negative number and multiply it by an even number of times, right, by 2 times or by 4 times, the negatives pair up and cancel each other out. So this is explaining what happens when I plug in negative x. When I put in negative x inside inside an x with an odd exponent, it switches the sign in front. But if I plug in negative x where I have an even exponent, it doesn't change the sign. So my shortcut way of telling you is all we have to do, look at all the exponents, right? Find the ones that are odd, right? Secretly, negative x is negative x to the 1st power. Find all the exponents that are odd, change the sign that's in front of them, and there you go. Now count the sign changes for the negative. So for finding the negative, you just change, you leave exactly negative x to the 6, right? Because 6 is an even number. You're only changing the signs in front of the terms with an odd exponent. Ooh, this is odd, so I got to change it to minus 4x cubed. This is an even, so I'm going to leave it, negative 2x squared. This is an odd, so I have to flip it, so it'll be plus x. And then this doesn't have an x, and I just leave it. So to find the number of negative possible roots, change all of the signs in front of the odd exponents, and then go through and see how many sign changes you actually have. Okay, that's a lot simpler than plugging in negative x and trying to think about it no, foolproof. Change the signs in front of odd exponents, and then just count how many times you have a change, right? Negative, 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 oh, to positive. Positive to negative, that is 2 sign changes. So I could have 2, and then if you subtract 2, I could have 0. So it's either 2 or 0, because these are the possible combos. I either could have 2 or I could have 0. I'm not going to have just one negative root. It has to be either 2 of them or none at all. Okay. Done?
Why did the negative 4 change to...
Because if you plug in negative x, a negative times itself 3 times is going to be negative. So it will change the sign in front of the odd exponents. That's what I was showing up here.
Wouldn't we get rid of the cube then?
No. I'm plugging in negative x, right? Negative x cubed. This is just going to be negative 1 times x cubed. So you just change the sign that's in front. You make the negative in front. Okay, so let's think. How many different combos are there here? So in order to illustrate this, let's have Jordan and Felix stand up. Yeah, just stand up real quick. It's all fine. Okay, ready? We are trying to dress Jesse, right? The options are Jordan sweatshirt, Felix sweatshirt. Options for pants, Jordan's pants, Felix pants. All right, let's think how many combos are possible?
4.
Okay, there's 4 combos. See, you guys know this, right? I could have, are you paying attention? Okay, ready? I could have Jordan's shirt, Jordan's pants, or Jordan's shirts, Felix pants. I could have Felix shirts, Jordan's pants, or Felix shirt, Felix pants, right? That's 4 combos. 4 combos. All right, thank you. Sit down. That's wonderful. Like, you guys like understand that. I remember doing this in like 3rd to 5th grade, right? Combinations. You have, 2 sandwich toppings and whatever, bread, whatever. Literally. So how many combos could we have here? How many different combinations could we have? This is literally sweatshirts, sweatpants. I could have 2 positive, 2 negative. Or I could have 2 positive and 0 negative. 2 combos. Ready? And 0 positive, 2 negative, or 0 positive, 0 negative. There's 4 different combos I could have. Do you see the analogy? Yeah, sweatshirt, sweatpants. There's 4 combos I could have. So that brings us to making the table. All right. Consider the total number of roots. Fill in with imaginary roots. So I have positive, negative, and imaginary. And we know how many rows we need. We need 4 rows because there's only 4 combos. Right? We just showed, right? There's only 2 sweatshirts and 2 sweatpants. There's only 4 combos. You're not going to wear just 2 sweatpants. Like, that's dumb. What are you going to do? Like, stick your hands through them? No, right? You have 2 options for sweatshirts, 2 options for sweatpants, 4 combos. You have 2 options. You either will have 2 or 0 positive roots. You either have 2 or 0 negative roots. There's only 4 combos. You can, like, mess with that.
That's a combo.
Okay. So first, you can have 2 positive and 2 negative. You could have 2 positive and 0 negative. You could have 0 positive and 2 negative, or 0 positive and 0 negative. These are the 4 combos we can have. We're just listing out by row the different like combinations we can have. So, how many possible roots are there though? Right? How can we tell how many possible roots we would have?
What?
How many possible roots can we have with this polynomial?
4.
Total number of roots. Total number of roots.
Infinity.
Green, louder. How do you know?
6.
Because it's x to the 6th power. That's the first thing I asked you when we went to this page. About something like x to the 6th power. How many possible roots? 0, 6 of them. That's the total number. Is the same as the degree. So the total number is going to be 6. So what you're going to do is add across, and it has to equal 6. Right? Imaginary is your filler. Imaginary is your filler. So the first line, 2 plus 2 plus what number is 6? 2. Okay, ready? So we put a 2 in there. Second line, 2
4.
plus 0 plus 1 is 6. 4. See, it's not like
And then 4 again.
4.
And then 6 on the top.
I see you. Okay, there you go.
6. Oh, you need it.
Yeah. You just
I agree. Yeah.
stupid as in like hard, or just like waste time? I warned you. Whatever.
Hey, don't you got me a tissue?
Are you passing notes?
No.
You should read it to the whole class.
What? Yeah, this is stupid. Just
bring it up to me.
Does it say Chucky done?
Oh my god.
I don't know why I asked. I don't know why I asked. Okay. So this is the table. This is the answer. This is the table. We're going to do.
That's the final answer.
What? You're really tired? I acknowledge it. I am sorry you're tired. Let's try to get more sleep in the future. You and I both. Yeah, me too. All right. So we are going to try it again. Ready? Sit down. Come on. Come on. I'm sorry. This is a zoo. I'm sorry. I tried. D period is better. Literally, D period is so much better. I'd never have to ask people to sit down or stop passing notes in my D period. Come on. Let's pick it up.
This is like the ADHD one.
The irony.
This kid sitting together.
I don't know. Whatever. He's gonna be gone soon. So which means I will move you over and have space.
So what?
Maybe I'll sit her between you guys. She'll help you. She knows what she's doing, huh? Okay.
How many more imaginary things?
Forever and ever. Okay. So let's try the next one. we are going to have complete silence, and you're going to try what we just did with this problem.
Try what?
This problem. What do you think I have on the board? Try this problem. Example 3. What we just did. Felix, turn around. Sit down. Come on. Come on. Focus. Focus. Y'all, I'm over it. You need to focus and try the problem. So over it. Just do the dang problem. Okay? I want you to have good grades in my class. I don't like giving out bad grades. Come on. What? We just did the example. Look at the previous page. We just did the example. Ah! God, I'm just gonna like.
You're very funny. Like naturally. I don't think you try, but you're very.
It gives me. You guys give me lots of anxiety because I'm like, dang. I worry about how you'll do on the test. The one that's on Tuesday that has this on it. Huh?
When do we get our
I'm gonna try to grade it tonight because I just had the last person take it today.
Can it be a partner test?
Oh no, I'm never giving you a partner quiz again. Good luck.
Why?
Sorry, can I rewind the screencast like 5 minutes and have you listen to yourself?
Wait, if I get 100%,
Okay.
can we get a partner test?
I am going to mark down everyone who's not working on the example right now.
I don't know.
Who's not working? Turn to the previous page and look.
Can I try? Previous page, I don't have my packet.
Now you wrote down the previous page notes.
No.
Yeah, exactly. You need to be writing it down. Exactly. I don't want to call you out, but you need to be writing.
Hey, alright.
I have a question.
What is wrong with you guys? All right, let's go. Done. Help me out. How do I find the number of positive? Hold on. Stop talking. Everyone needs to be sit up. Jordan, sit up. Okay, try it. Hold on. I'm gonna wait. People talking. There's noise. Okay. All right, done.
Check how many times the signs change.
Exactly. For the positive, just look at the sign change. How many do we have?
Twice.
1, 2.
No, 3.
So it's it's 2.
It's 2.
So
One
it's
of the
2.
five. One of the
It
five
was
is five.
subtracted by 2. So it's 2 or 0 times the result.
Exactly.
Why not 5?
What do you mean?
The fifth power, it's an odd number.
This is a positive. We're seeing how many times we switch from positive to negative, negative to positive. There's not a negative sign right here. It's positive.
But the 3 is also positive.
Yeah, exactly. That's why I don't switch. So I have 3 to negative. I'm going from a positive to a negative. I'm switching from a positive to a negative. So it's a 1 switch. Question. Yeah, that's fine.
Wait, so it's from the positive to the negative and then the negative to the positive? Or
That's
from
a
the
second.
negative to the negative?
So now you're switching. So, ready? I start with 2x to the 5th. Ready? I'm starting positive. Here's positive. And then I'm positive. Okay, you know what? It's Vanna White time. Let's do this. Okay.
What?
Vanna White. She does Wheel of Fortune. All right, ready? Positive. Positive. Ready? X to the 4th. Positive. No switch. No switch. Dylan, come up here. I need you to count with your fingers how many sign changes. Whenever I say switch, you gotta like put up a number. Okay, ready? Positive. Yo.
Oh, you face the switch!
I didn't say switch yet.
When she said switch, put up
Ready?
a finger. I'm telling about it.
Is this positive or negative?
Positive.
Okay, ready? X to the 4th.
Positive.
Positive.
Switch.
No, I have not switched yet. X3. Positive. Oh. I'm switching negative. Okay.
What part is switch,
And
bro?
go to
Yes.
negative, and then switch.
Poor Dylan.
Hey, switch! Yeah, let's go! That's 2
How
switches.
many switches do we have?
Dude, that's all.
Two. And subtract 2 is 0. Okay.
Good job. You switched it hella good, Dylan.
Don't you get participation for that?
He is.
You should.
Hey, wait, do I get participation for standing up?
Best
No.
thing I've heard all day.
No, I literally asked him to stand up there.
I could have. Oh, we stood up. We stood up for our pants and sweatshirts.
Yeah, but you guys have also been screwing around today, so I moved that. Okay.
So we're even.
Not quite. Okay, let's do the negative. Okay, so the number of negative. So what I need to do is I'm going to switch the sign in front of any exponent that's odd. So here, I'm circling my odd ones, and I'm going to switch the sign in front of them. Negative 2x to the 5th, I leave the plus x to the 4th. Negative x to the 3rd, I leave the minus 4x squared. Plus x plus 9. Now that I have that, we'll go through. We're going to see how many times we switch. Yes, done.
So then you add a negative to
I'm switching the signs in front of the variables with odd exponents.
Oh, okay.
That's why the only ones that switched are the ones I circled in red.
I get it.
So I have negative, negative to positive, switch, positive to negative, 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 negative to positive, and then that's it. So I have 1, 2, 3 switches. Ah,
3 or 1.
exactly. Subtract 2 or 1. Okay. What?
Yeah, I did that the first time.
Sweet.
You always subtract 2.
Yes, always 2 until you reach 0 or 1. So guess what? If you count an odd number, you subtract 2 until you reach 1. If you count an even number of times, subtract 2 until you reach 0.
So when do you do that?
What?
When do you subtract?
I have 3. From 3, I subtract 2. What's 3 minus 2? 1. Okay. Yeah. Okay, so now we need to make our table. Positive, negative, imaginary. How many combos do I have? How many different combos?
4.
So I have 4 combos. 4 combos. Because there are 2 options for positive and 2 options for negative. It's kind of like you have 2 shirt options, 2 pant options. You're not just going to wear 2 shirts. You can't just come to school with no pants on, all right? You have to have one of each. And you only can have one of each. Okay. So, here's our options. Okay, you know why I say that? It's because that's what my D period. They're like, well, you could have like 2 pants. No, you can't. You know, okay. I'm sorry. I'm trying to make it relatable and interesting. You do you. Okay, 3, 1, 3, 1. Okay. Here are my combos. I can have 2 positive, 3 negative, 2 positive, 1 negative. 0 positive, 3 negative, 0.
Oh, I low-key get this. I understand it.
Alright, done. Here we go.
It has to equal to 5
How do you know?
because that's the biggest exponent.
Exactly.
I understand this now.
And then the I, you just like.
And then the I is the filler. 2 plus 3 plus what? 0? 2, 2, 4. So notice, imaginary roots come in pairs.
I didn't.
Okay, so we did the rational root theorem? Hold on.
This is like something I feel like I'm gonna use every day.
That's our next lesson. Okay. So tomorrow.
Oh, we're done?
No, we have a whole example. Look at your notes. Come on. Context clues. Okay, here's the deal. So, when we use it, there's this thing called the rational root theorem. If you're trying to factor something like x to the 11th power, like with all these terms, like no way. But what you can do is figure out, there's this way, which we learn tomorrow, about all the possible rational roots. So instead of having infinite number of options for roots, you can have like 10. And then you know at least one of those 10 will be a real root. So if we know, okay, well, we can't have any positive roots, that helps us because, then I don't have to try any of the positive numbers. So tomorrow I'm going to reference this a bunch. In retrospect, I probably should have done tomorrow's lesson first before this one.
Do you have an example of this? Is that low-key thing I could do?
What? Not gonna lie, when I learned about rule, like Descartes rule, was my first year teaching here because people complained about it, and I was like, what are you talking about? Rule of signs.
You understand that fast? Wait, I'm just confused.
Yes.
Where do you get those 2 numbers from? Like, I know you get, I'm just confused.
The imaginary, the purple ones?
No, I get the imaginary. Once you get, but the blue and the red, like, where do they come from?
Yeah, facts. Where do you get the blues from?
So you can have 2 positive, 3 negative, right? 2 positive, 3 negative.
Oh,
You can have 2 positive, 1 negative, right?
oh, so you're matching up your positive.
Yes.
and
These are my combos. Every row is giving you a combo. Literally, Felix sweatshirt, Felix pants. Felix sweatshirt, Jordan pants. Jordan's sweatshirt, Felix pants, or Felix sweatshirt, Jordan's sweatshirt. You like?
No, I get it though.
Like you see, I have to have all the combos.
I see. So,
Miss
O'Brien.
But no, the positive stands for sweatshirts. The negative roots are the
Yeah, but
sweatpants.
you said. Oh, wait. No, never mind.
Okay, so I want to get through the last example. Okay, we have one more example. And then guess what? There's even more examples. Oh my gosh, if we have time and we can go through them. Oh, I'm sorry. I'm trying to help you understand the content by giving you more examples for you to come and help yourself a bonus. Like, my bad. Trying to help you.
Oh, I got it.
Just because of like people were still really lost after that one, I was like, okay, we'd go do another. But it seems like we're okay.
I feel like it's just like.
I acknowledge your opinion, but I just whatever. Question?
Alright, can you scroll on, please?
Yeah, let's just get through it.
If the blue were say 3 or
Felix,
1, in the chart would the blues be 3, 3, 1, 1?
yeah.
Okay.
The only reason I wrote it that way is because I have to match up, right? I have to have the 2 match with the 3 and the 2 match with the 1. Does that make sense, the way I ordered it?
Oh, yeah.
Because I don't want to have like, oh, 2 and 3 and then 2 and 3. Like, no, it's the same thing. I don't want to have this exact line here as well.
Oh.
That's why. Right? I wanted to like have it match up with either one. Yeah, I need to make sure. Because combo 1, Felix shirt and Felix pants, shouldn't be the same as combo 2, Felix shirt and Felix pants. That's not a different combo. It's the same thing. Okay, Cooper and then Jordan.
I don't even know why I was raising my hand.
All right, cool. High five, Jordan.
For some reason.
What if the 2 on the top left was a 3 and you had to get 5? It would be negative.
So it wouldn't be. If the top number, if it was like 3 and 1 with the blues, it would have to be 2s and 0s for the reds.
Well, okay.
Yeah. Just the way, because the way it switches, like that won't be able to happen. It always will match up like this. Okay, so complex conjugates. So complex conjugates, literally all you do is switch the sign of the imaginary number. So I'm going to write that so you write it as well. Switch the sign of the imaginary number. So if I have a complex conjugate, so complex means it has a real part, has an imaginary part. A plus BI, right? A is the real part, the BI is the imaginary. So if my example, if I have like 2 plus 3i, the complex conjugate, all I do is I switch the sign in front of the negative. The complex conjugate would be 2 minus 3i. That's it, right? That's switching. That is the complex conjugate. So here's the deal. If 2 plus 3i is one of my roots, and I just said imaginary roots come in pairs, the second, right, the pair would be the complex conjugate. That means 2 minus 3i would be a root. So throw back to the second problem we did today, where I had 4i was a root. Remember, way up here, right, we said 4i was a root. The complex conjugate would be a root as well. So you put a negative sign in front of the I. Oh, negative 4i is a root as well. They always come in pairs, and they're always complex conjugates. They always are opposite signs of each other, right? The sign in front of the imaginary always flips. Okay, so back to this. This is the last example we're doing today. So if 3 plus 4i is a 0 of this polynomial, then that means 3 minus 4i also has to be a 0 of the function. So one of the very first things we did today is we talked about roots and we talked about factors. So I want to write a polynomial of least degree with this with zeros which include 4 and negative I. So for x equals 4 is a root, x equals negative I, but I thought imaginaries come in pairs. What is the complex? What's the conjugate I'm missing? Let's see, Kaden, do you know what root am I missing? So imaginaries always come in pairs, so I need the complex conjugate. No, I need the imaginary complex conjugate. It would be positive I. Positive I. Since negative I is a root, the complex conjugate, exact same thing. All you do, switch the sign in front of I, would be positive I. Right, another example, it's not part of this problem. If I have like 3 minus 2i, what would the complex conjugate be? 3 plus 2i. Okay, so here's the tough part. I'll give you a problem just like this. You have to write in the complex conjugate. I'm not going to give you both. I'll give you one, and you have to realize imaginary, come in pair. You have to write the complex conjugate. Okay, So I have 3 zeros. I need to make them into factors so I can multiply them all together and have a polynomial function. Let's write them out. So this would be x minus 4, right? Because you subtract 4 on both sides, and then you have x minus 4 equals 0. This would be x plus I and x minus I. Okay, so we need to multiply these together. But we only want to do like 2 binomials at a time. So the easiest way to do it is let's do these 2 first. Looking for one word, answer, how do I multiply these together? FOIL. FOIL, let's FOIL them out. First, outer, so minus I times x, inner, plus I times x, last, minus I squared. What happens to these 2 parts in the middle? Yeah, they cancel. Also, negative, so I squared is -1. So if I'm subtracting a negative, it's +1. So I have x squared minus a negative, so this is x squared plus 1.
Damn.
Bring down our other factor. Now we just have to FOIL our 2 binomials again. Wonderful. So try to FOIL this yourself. All right, as I walk around, I should see everyone writing this out. You should be writing this out on your paper, the whole thing. Doesn't matter. You should be taking notes the whole class period, writing what we're doing. So these last 2, you should have this written down. Try it out. So I want to write it in standard form. Standard form means highest exponent on the left, and then it just cascades down. So highest exponent, so I have x to the 3rd minus 4x squared plus x minus 4. This is the polynomial with least degree. So think about it, least degree. How many roots do we have? 3. 4, negative I, positive I. So what is the exponent I should end up with? Biggest exponent? 3. Yeah, there we go. That's the smallest. The reason we say least degree is because I could multiply this by x plus 1 and then multiply by x minus 2, and I could find a x to the 5th polynomial that technically has those roots, but I just want the polynomial with only those roots. Dude, what the heck? Okay, do we have questions about this one? So, do we need another example with Descartes? No. Okay, so you guys have exactly 8 minutes where you can work on homework or Alex.
Do you have a homework, sir? What?
Yeah. It's just I'm trying to give you guys a couple extra problems every time, because if we need them, we have them. If you need help specifically, you come to bonus, and there's problems where it's known to work. Yeah. Okay. Jesse, you going to the bathroom or not? Okay.
Mr. Ryan, do you have a phone?